Welcome to Ask and Learn.
Hi everyone, here it is given that 100 millimeter radius brake drum. So radius of brake drum is given 100 millimeter. Is attached to the flywheel which is not shown in figure. The drum and flywheel together having mass 300 kg and radius of gyration 600 millimeter. The coefficient of kinetic friction between the brake band and the drum is given 0.3. Knowing that the force P having the magnitude of 50 Newton applied at A when the angular velocity of flywheel is 180 rpm. In counterclockwise direction. Determine the time required to stop the flywheel. Time for flywheel to become at rest given A is equal to 200 mm and B is equal to 160 mm. Now see the force distribution. Suppose this in this cord tension is T1, T2 and T1. This is 50 Newton given already. A is 200, B is 160. This distance will be 40 mm. Now all the values are in millimeter. The moment of force about C point must be 0. Now calculate this value. 50 into AC. AC is given 200. We are taking in mm plus T2 into T2 and this distance is 40 mm. So T2 into 40 minus T1 into this will be 160 mm. So you will get 4T1 minus T2 is equal to 250 Newton. This is say equation 1. Now moment of inertia of the flywheel and drum I will be m into k square. Mass is 300 kg. Radius of gyration is 0.6. So moment of inertia of the system would be 108 kg meter square. Radius of drum is given 0.1 meter. Now see the geometrical view of the drum. This is center. It is T2. This is T1. I into alpha. This is O point. So for summation of moment about O, we can write T2 into R minus T1 into R is equal to I into alpha. So from here you will get, you may take R common. So T2 minus T1 you will get I alpha upon R. Or in terms of T2 minus T1, alpha can be written as R upon I T2 minus T1. R is 0.1 meter. I is just, we have calculated 108. T2 minus T1. So angular axle retardation of the drum we can write 925.93 10 to the power 6 into T2 minus T1. Say this equation is 2. We can write the relation between potential in the belt T2 upon T1 to be exponential of mu k into angle beta, that is T2 is equal to T1 mu k is given is 0.3, beta is 180 or pi radian. Substituting in equation 3, so T2 is equal to T1 exponential of, that is T2 is equal to 2.5663 T1. This is equation 4. Substituting this value in 1, so by solving equations 1 and 4, we can find T1 and T2. T1 having 174.38 Newton and T2 is 447.51 Newton. Putting in equation 2, you will get angular retardation alpha. Alpha will be 925.93 10 to the power minus 6 into 447.5 minus 174.38. So angular retardation you will get 0.2529 radian per second square. This is the retardation, not the acceleration. Now we have to calculate the time in which wheel and drum will come at rest. You know, omega naught is given 180 rpm or 180 into 2 pi upon 60 radian per second. So this would be 18.85 radian per second. Alpha is negative, mine because it is retarding 0.2529 radian per second square. Finally, it is coming at rest. We have to calculate the t. So use the equation omega is equal to omega naught plus alpha t. So you will get 0 is equal to 18.85 minus alpha is 0.2529 into t. So time taken to come to at rest is 74.5 seconds. That's all for this problem. Thanks for watching it.